let's look at two game theories problems. First one, consider the case of two dry cleaning firms A and B. So players are firm A, firm B. Each firm is making a strategic decision on whether or not to lower the price or not. So here is the payoff matrix for firm A and B, where the action is cut price by 20% or don't cut. Okay, given this, we need to find whether firm A and B have dominant strategy or not, and whether does these duopoly games have a dominant strategy equilibrium and Nash equilibriums. Okay, so let's check whether firm A has dominant strategy or not. The way to check for dominant strategy is mechanical. We just ask these two questions. First, if B cut, what will A do? So if B cut, then we are in these columns. By the way, the first payoff belongs to firm A, second payoff belongs to firm B. Okay, if B cut, then we are in these columns. So firm compare this with this. Then clearly $160 is higher than $80. So A will cut. If B not cut, what will A do? If B not cut, then we are in these columns. So A is compare this payoff with this payoff. Okay, so clearly $260 is higher than $200. So A will cut. So A will not cut, sorry. So we see that A's strategy depends on B. So A does not have a dominant strategy. Similarly, you can check whether B have a dominant strategy or not. And since not all players have a dominant strategy, we do not have a dominant strategy equilibriums here. However, we do have a large equilibriums. So let's check for large equilibriums. Or more strictly speaking, pure strategy large equilibriums. So we have 4 pairs of strategies here. Let's check this, which is cut and cut. So a large equilibrium is a strategy profile such that given the other player's strategy, nobody has incentive to deviate. So we are to check for large equilibrium, we can just follow the definitions. So given A cut, will B deviate or not? Okay, given A cut, then we are in these rows, will B deviate? So D needs to compare this payoff with this payoff. So clearly $120 is higher than $40. So the answer is no. Okay, first question. Second question, given B cut, will A deviate? So given B cut, we are on these columns. So A need to compare this payoff with this payoff. And clearly $160 is higher than $80. So the answer is no. So now we get a negative answer to these two questions. So we see that indeed, given the other player's strategy, nobody has an incentive to deviate. So this cut and cut is indeed a large equilibrium, a pure strategy large equilibrium. And I'm going to lead you to check the other 3 cells. Alright, that's how to find a dominant strategy. Check for large equilibriums. Pure strategy large equilibriums. Okay, let's look at the next one. Consider the below payoff matrix for vampire bats 1 and 2, whose payoffs are the utilities they acquire from the amount of blood they consume, which depends on whether they share their own successful hunts with each other or not. So the action is share or conceal. It has been suggested that the vampire bats live life in the prisoner's dilemma. We want this game to be a prisoner's dilemma. For what values of A and B will this be the case? Okay, we want this to be prisoner dilemma. We need 2 things. First, both players have a dominant strategy, and dominant strategy equilibrium is not the best outcome. So there's a better outcome that cannot be achieved there. By looking at this payoff matrix, by the way, the first payoff belongs to vampire bat 1. Second payoff belongs to bat 2. Okay. By looking at this payoff matrix, so we want, okay, the dominant strategy equilibrium to be this, such that there's a better outcome here. Share and share better outcome there, which cannot be achieved. So want conceal to be the dominant strategy for both bat 1 and bat 2. Okay. So let's check for bat 1 first. So we know how to check for a dominant strategy. Okay, let's say if bat 2 share, we want bat 1 to conceal. So if bat 2 share this one, when we are in this row, we want bat 1 to conceal. So which means that now bat 1 is going to compare this payoff with this payoff, which means that we want bat 1 to conceal. That means A is bigger than 10. Okay. Second, if bat 1 conceal, bat 2 conceal, we want bat 1 to conceal as well. So that conceal will be bat 1's dominant strategy. If bat 2 concealed, then we are in this row. So now bat 1 need to compare this payoff with this payoff. So we want bat 1 to conceal, which means B will be less than 5. We need for values of A and B, we need to satisfy these 2 conditions. Or A is bigger than 10, B is less than 5. And I will leave you to check bat 2. It is exactly in the same way, and you will end up in exactly having the same answer here.